This slide set walks along with section 6.7, pulling everything together and looking at how a single web request is resolved and the response is delivered to the browser. First, we bring our laptop to the school network and open up a web browser to load www.google.com. So, how actually this one works? When we bring a laptop to campus, it does not initially have its own IP address. So, we need to use DHCP to obtain an IP address and other important information from the campus server. The request is encapsulated in a UDP datagram, IP datagram, and Ethernet frame. The Ethernet frame with the DHCP request is broadcast on the LAN and received at the router, which is also the DHCP server. Once received, the DHCP request is sent up the stack to the router to the application layer. DHCP server finds an IP address for the laptop and creates the DHCP reply. The application layer packets is sent through the stack and encapsulated in an Ethernet frame and forwarded back through the network to the laptop. The switch uses the laptop's MAC address to identify where it should be delivered. The client receives the reply. Now it has an IP address and knows the IP address of its DNS server and its first hub router. Now we want to get back to sending the HTTP request to www.google.com. But before we can do that, we need to know the IP address of www.google.com. So we need to ask the DNS server whose IP address was obtained through the DHCP. When the DNS request gets down to the link layer, Ethernet, the link layer realizes that it does not know the MAC address of the first hub router. We cannot send the Ethernet frame without a MAC destination. To find the MAC destination, we need to use ARP. The ARP query for the MAC address of the first hub router is created as sent. The reply is received containing the MAC address of the first hub router. Now the MAC address can be inserted into the destination address field in the Ethernet frame, and the DNS query can be sent. Now we are ready to send the DNS request. The frame is forwarded to the first hub router. The router looks at the IP datagram destination and finds that it needs to be forwarded to the Comcast network. The router forwards the IP datagram with the DNS request to the Comcast DNS server. Since www.google.com is a popular website, the DNS server has its IP address cached, so it can provide the IP address back to the client. Now we have the IP address of the www.google.com web server, 64.233.169.105. We construct the HTTP request at the application layer. But when we reach the transport layer, TCP, there is no existing connection. So that has to be set up before the HTTP request can be sent. To set up the connection, the client sends a SYN packet. The SYN packet is routed through the network to the Google web server. The SYN is sent up the network stack to the transport layer. A SYN ACK is generated to continue with the connection setup. The SYN ACK is sent back to the client. Once received, the connection is considered to be established. Because the client will have data to send the HTTP request, the final ACK is the three-way handshake will be included in the HTTP request packet. Back to the HTTP request. Finally, we are able to send the HTTP request into the newly created TCP socket. The request is routed to the web server, with each router looking at the destination IP address. The packet is passed up the stack and delivered to the application layer. The web server finds the request page, builds the HTTP response, and sends it back down the stack. Then the reply is sent back to the client. The packet is delivered and set up the stack at the client to the application layer and browser. Finally, the web page can be displayed.